Solutions are a homogeneous mixture of two or more substances. So when we have a solution, there's two components to a solution. One is the solvent and one is the solute. The solvent is the component that does the dissolving. It's usually the one that's present in the greatest amount. And the solute is the component that gets dissolved. So you can think about the solvent as being the one that dissolves the solute. When we have an aqueous solution, water is the solvent. So we would have something else dissolved in water. And quite frequently we will use aqueous solutions, and you will see those designated as AQ sometimes. So of course we want to be able to measure things about our solution, so we can measure the concentration of our solution. The concentration is the amount of solute in a particular amount of solvent. Most frequently we use units of molarity to measure the concentration of a solution. The concentration of a solution, when we calculate in terms of molarity, is moles of solute per liter of solution. So these are key points here, that the amount of solute has to be in moles and the volume has to be in liters. So sometimes we will abbreviate that as molarity, and molarity is abbreviated as a capital N. Molarity is equal to moles per liter. So let's take a couple of examples of calculating molarity. We want to know the molarity of a sodium chloride solution if 0.50 moles of sodium chloride is dissolved in 500 milliliters of water. Now we said on the last slide, molarity is moles per liter, which means we've got to convert milliliters to liters. So we have 500 milliliters of water, and we know that there are 1,000 milliliters per liter. So if we divide 500 by 1,000, we come up with 0.5 liters. Now be careful not to add extra significant figures. 500 does not have a decimal in it, which means that those zeros are not significant. So there should only be one significant figure when we convert milliliters to liters. If you put 0.500, because there's a decimal, these zeros become significant, so now you've changed this to a number that has 3 significant figures. So we can't change the number of significant figures, which means we're going to round this off to 0.5 liters. So now we want to calculate the molarity. Molarity is equal to moles per liter, and we're given 0.50 moles and 0.5 liters. So 0.5 divided by 0.5 gives us a 1 molar solution. Now let's take this a step further, and this time we're given a problem where we have grams instead of moles. So we have to convert grams to moles, and we have to convert milliliters to liters. So we have 36.5 grams of barium chloride. And if you calculate the molar mass of barium chloride, it comes out to 208.23 grams per 1 mole of barium chloride. So if you divide 36.5 by 208.23, we have 0.175 moles of barium chloride. So we need liters is the other piece of our component of our calculation here. So we have 750.0 milliliters. And there's 1,000 milliliters per liter. 750 divided by 1,000 comes out to 0.7500 liters. So now that we have moles and we have liters, we can plug that into our molarity formula. So we have 0.175 moles divided by 0.7500 liters. So if you put that into your calculator, you should come up with 0.234 moles of barium chloride. Now, let's take a different type of problem. A student wants to prepare exactly 250 milliliters of 0.500 molar potassium hydroxide solution. And we need to know what mass of potassium hydroxide the student needs to dissolve in water in order to make a 250 milliliter solution. So this time we already have the molarity, and we need to find out how many grams of potassium hydroxide we need to start with. So if we have that molarity is equal to moles per liter, we can't calculate grams from this, but we can calculate moles. And we know how to go from moles to grams, so if we calculate moles, then we can use that to get grams. So if we rearrange this equation, algebraically, moles is equal to molarity times liters. Now, you can rearrange these algebraically, or you could memorize all three ways of arranging the equation so that you can calculate molarity, moles, or liters, which would be a lot of memorization for you. Or if you like a little shortcut way, one thing you can do is you can draw a triangle and think about this in terms of what you're trying to find. So in the previous problems, we've been calculating molarity. So that would mean that we don't have molarity. So we would block out molarity, and if we're trying to find molarity, what's left is moles and liters. So you would divide, because moles is on top, you would divide moles divided by liters. Now, if you're trying to find moles, we don't have moles, so we're trying to find that, so we would cover that up, and molarity and liters are side by side, so you would multiply molarity times liters. If you were trying to find liters, then you would cover up liters, and you have moles and molarity left, you would divide moles by molarity to get liters. So this is a little visual that you can use to help you remember. Or you can rearrange the equation algebraically. So in this case, we're looking for moles, so whether you rearranged algebraically or you use the triangle shortcut, you get moles is equal to molarity times liters. So we have a 0.500 molar solution. 250 milliliters, if you convert that to liters, that comes out to 0.250 liters. So 0.500 times 0.25, and we can't add significant figures here, so this should just be 0.25 liters. So that comes out to 0.125 moles of potassium hydroxide that we need. Now the question asks us what mass of potassium hydroxide, and mass needs to be in grams. So we're going to take 0.125 moles of potassium hydroxide. And if you calculate the molar mass of potassium hydroxide, that comes out to 56.11 grams of potassium hydroxide. So moles cancels with moles, and 0.125 times 56.11 gives us 7.01 grams of potassium hydroxide that we would need to measure out. And actually, this should only be two significant figures, so we would actually round this off to 7.0. Now, what if you already have a solution, but it's more concentrated than what you need? Well, what you can do is you can take your stock solution, and stock solution is the concentrated solution that you're going to use to make your solution of lower concentration. So you can think of the stock solution as the solution that you started with. And we're going to perform a dilution, which means that we're going to add some of the solvent to lower the concentration. So there's an equation that we can use for a dilution. The equation is M1V1 equals M2V2. So the original concentration times the original volume is equal to the new concentration times the new volume. So let's take an example and dilute a solution here. So hydrochloric acid is obtained in 12 molar stock solution. We want to know what volume of stock solution is required to make 500 milliliters of a 0.145 molar dilute solution. So we're going to use our dilution formula, and our original concentration is 12 molar. And we want to dilute this to 0.145 molar, and we want 500 milliliters of that. So we have to find out what volume of that 12 molar stock solution we need. So then we're going to take M1V1 equals M2V2. So M1 is 12 molar. Now you can leave the volume in milliliters so long as your units are the same on both sides. Because we have volume on both sides, and milliliters and liters are proportional, as long as we keep them in the same unit, we can leave this in milliliters. Now, if you were given both volumes and you were trying to find molarity, if one of your volumes was in liters and the other was in milliliters, you would have to put them in the same unit. but as long as in the same unit, you can use either liters or milliliters. So we're going to divide both sides by 12 molar. So if we take 0.145 molar times 500 milliliters and divide this by 12 molar, V2 is equal to 6.04 milliliters. So let's take one more example here. If 0.850 liters of a 500 molar solution of copper nitrate is diluted to a volume of 1.80 liters by the addition of water, what is the molarity of the diluted solution? So this time we have volume given to us in liters, but they're both in liters, so we can keep them in units of liters. So we're going to have M1V1 is equal to M2V2. So we have a 5 molar solution to start with. And we started with 0.850 liters of that solution. And we're going to dilute it to 1.80 liters. So we divide both sides by 1.80 liters. And M2 is equal to, if we take 5 molar times 0.850 liters divided by 1.80 liters, we come up with 2.36 molar. Okay, so we will stop here, and I will see you in class, and we will get some more practice with this.